Hi everyone, my name is Jacob and welcome to my basement. Recently I was doing some Christmas shopping and while walking around the shelves I came across something really interesting. I think you might like it. This is a so-called lead glider. It's made from a durable foam, it's really light and it's also dirt cheap. This model costs only $5 and you know, it flies really well for its price. I'm actually surprised how well this toy is made. So I just couldn't resist and I bought a couple of them. Here you can see how the box looks like. Yeah, it's basically this. And they have wingspan of almost 1 meter, so that's honestly a great test platform. And I really wasn't surprised when I found out that there is a huge RC community around these lead gliders. People make all sorts of things from them. The builds range from quite simple to really impressive to surprisingly bizarre. But they all seem to fly really well. And you know, airplanes are always cool. But recently I wanted to build something more advanced. Something that goes beyond just flying forward. And now when I have this good platform to experiment on, I think it might just work out. So in this video I will try to turn this lead glider not only into Ardupilot Plane, but into fully functional Ardupilot VTOL Quadplane. Seems interesting? Well, keep watching and let's get to work. If you don't know, VTOL stands for Vertical Takeoff and Landing, and I think it can be called a holy grail of modern aviation. Because what it does is basically combine the best features of both airplanes and helicopters into one single machine. Good example is one of my all-time favorite aircrafts, the V-22 Osprey. It can quickly and efficiently cover long distances just like a plane, thanks to its wings and forward-facing motors. But when it has to land, the Osprey can simply tilt these motors upwards and it can land in place just like a helicopter. That's why the Osprey doesn't need a runway and it can simply land wherever it wants. So you can see how many advantages VTOL capability can bring to an aircraft. And the same applies to drones. Except here it gets even more interesting, because there are dozens of configurations that you can choose from. And of course Ardupilot, being an amazing flight software it is, can run them all. So to make it simple, drone VTOLs are divided into two main categories: fixed rotors and tilt rotors. Previously mentioned Osprey would be qualified as tilt rotor, and so are all the other crafts that use thrust vectoring. There are also subcategories that focus on the way the aircraft is landing or taking off. For example, this weird Conver Pogo VTOL would be considered as tailsitter because it, well, sits on its tail. Just like that. Each of these designs has its own unique advantages, but for my first VTOL project I want to pick the most proven platform. And so I decided on a fixed motor multicopter plane. I think I already have an idea how to convert this glider into one. But before I tell you, let's talk about today's video partner, NordVPN. If you're like me and you care about your internet privacy, you probably realize how hard it is to keep your data safe while browsing online. Because no matter which site you're on, you're always just one click away from catching some very nasty malware. And that also applies to ads, which are getting more and more intrusive. Luckily, NordVPN has a special threat protection feature, which can scan your downloads and make sure there are no safety risks. Threat protection can also block all the annoying ads, to get you the smoothest and safest browsing experience you can get. And of course, on top of that, you get the core VPN functionality, which means you can basically choose any place on Earth and start browsing from that direct location. It's an incredibly useful option if you are doing some research or online shopping and you don't want to limit yourself to only your country's search results. It's also great if you want to access region-blocked websites, like for example here I wanted to try the new Sora AI, but I can't do it from Poland. So 2 clicks later, my internet location is now in the US and I can easily log in. There are many such cases, so if you value your online privacy and internet freedom, don't wait and go to nordvpn.com/basementcreations to get signed up with a special creator deal. By clicking the link in the description, you can get 2 years plan with 4 extra months and 30-day money-back guarantee. So again, nordvpn.com/basementcreations. There is simply no better deal than that. And now, let's get back to our plane. Alright, so first let's talk about the parts that I choose for this project. First of all, for the flight controller I picked the SpeedyBee F405 Wing Mini. It is designed with Ardupilot in mind, it has a lot of PWM outputs and it doesn't cost a fortune. Next, to control the motors, I will be using two SpeedyB 4-in-1 mini ESCs. And speaking of motors, for the vertical lift I got 4 Beta FPV 1805s, and for the plane horizontal propulsion I also got 4 GPRC 1106s. For this project I'm also super excited to test a new sensor, the PX4 Python tube. It will be used to get the real airspeed values, which is very important for VTOL planes. And there are also other components like servos, propellers or batteries, so I will put the whole list in the description. Now, to make sense of all these parts and the way they should work, I created this simplified model in Fusion 360. For starters, I'm planning to cut some foam from the tail and wing tips to make room for control surfaces. Then I want to reinforce the whole airframe by gluing 2 carbon tubes inside the wing and 1 additional tube inside the tail. This should result in much stiffer plane, which is especially important for VTOLs. Next I want to attach 4 puller motors to the front of the wing, a configuration similar to planes like A400 or C130. While this setup is probably going to be heavier and less efficient than just one bigger motor, it has an added benefit of redundancy, and we can also use the motor's differential thrust to replace the rudder. And most important, I think it just looks cool, so I'm sticking with this idea. And once I get this thing to fly, I can add sensors like Python tube in the front to get undisturbed airspeed readings. And now, to actually convert it into VTOL, I want to mount 2 long carbon fiber tubes underneath the wing, to which I can later attach 4 vertical thrust motors. As you can see, the front motors are extended further to the front, and that's because they need to be symmetrical to the center of gravity, which is usually at about 75% of wing chord length. Looking at this plane, I can already see some problems, and I bet you can see them too. I also have no idea how it will do in the air, but I guess there is only one way to find out. To start the actual build, first I got to work on the tail. The original horizontal stabilizer has a slight angle at the back, so I cut a piece from it to make it straight. Next, it was just a matter of cutting a similar piece from balsa wood and then creating a hinge from reinforced tape. In the middle of this new elevator, I glued the 3D printed carbon nylon servo horn and then connected it with a long metal linkage. This linkage of course must be attached to a servo, so I used a Dremel tool to create a square hole in the rear fuselage and then glue the servo inside. Using a Dremel to cut in this foam is not always ideal, which I found out while carving the path for the tail carbon tube. It came out ugly and too wide, so I had to use a lot of hot glue to fill the gaps. But nevertheless, it did help to stiffen the tail, and after gluing the stabilizer in place, our tail modification is complete. Now, in the front part of fuselage, I cut out the black canopy and then removed a lot of foam from the inside to make space for electronics. Right behind, under the wing, I also removed some foam to fit in the battery. On the sides I also glued the battery straps to keep it in one place. Then I connected both of these chambers with a balsa plate to strengthen the now empty nose and also to have a nice mounting place for ESCs and flight controller. For now I think the fuselage is ready, so let's do some work on the wing. First thing to do is draw all the guidelines from the CAD project. Then, using a low temperature soldering iron, I slowly removed all the foam from where the carbon tubes will be. The soldering iron does a much cleaner job than Dremel tool, and so the tubes fit snugly inside the canals. Now the problem I see is that the carbon tube is straight, but the wing is definitely not. Out of the box, the wing is bent up in the shape of dihedral. This design choice improves flight stability, which makes sense for a toy glider, but it is quite troublesome for my modifications. And that's why we have to make it straight. There are many techniques for doing that. I tested the ironing and hot water without much success, but then I discovered that wrapping a towel around the wing really helps with spreading the heat. Once you leave it like that for a few minutes, the foam becomes quite plastic and you can bend it as you will. After this procedure, I put the wing on the floor and covered it with heavy boxes to straighten it even more. And just like that I got almost perfectly flat wing. Then I could simply glue the carbon tubes inside the canals, which created a really strong and stiff wing, perfect for VTOL modifications. And as you can see, I have already installed the motors and aileron on the side. Making the ailerons was very similar to the elevator. I cut a rectangle from the wing tips, then got a piece of balsa wood and made a hinge out of tape. I removed some foam from the wing and glued the servo inside, so that it doesn't affect the airflow. Last step was to glue the 3D printed horn and connect it to the servo with special linkage. To attach all the motors, first I screwed them to the 3D printed mounts. Next I created 4 new canals perpendicular to the main wing spar, and then inside the canals I glued short carbon tubes. This design allows you to easily swap the motors by just sliding the mount on and securing it with an M2 screw. Once I got it all in place, I did some cable management so that every connection goes nicely through the foam and into the cockpit. However, under the canopy, the wiring mess was hard to manage, because here the 3 servos, 4 motors, GPS unit, LRS receiver and battery all connect to the single SpeeDB flight controller and its ESC. I also added the connectors for airspeed sensor, Voxnail FPV camera and USB. It's really easy to get lost in all these connections, so I prepared a special wiring diagram. All this stuff unfortunately has its weight, and so my modified glider weighs 375 grams on itself and a bit over 500 grams with my 3S lithium battery. And considering that out of the box it weighs only 160 grams, I think my build turned out to be a bit too heavy. But then again we have 4 motors and a sizable wing, so it still might fly well. And to improve the flight I mounted the pitot tube on the left side of the nose, and then on top of the cabin I attached the Voxnail FPV kit. Now the last thing to do is plug in the SpeeDB USB connector and jump right into the Ardupilot setup. Alright, so my plan here is to prepare our lead glider for the first flight and see how it performs as traditional plane. I have already built several Arduplane aircrafts on this channel, so you can find detailed setup guides there. In this video I want to only focus on the unique features and of course later the VTOL configuration. But don't worry, I will post all the parameters somewhere in the description as usual. So, first thing, the servo output tab. Here, because we have 4 motors, I set PWM outputs from 5 to 8 as throttle. This lets us control them all the same way we control just one single motor. Keep in mind though that they can't all rotate in the same direction, or you might get some nasty torque effects. So in my configuration they spin like that. However, this setup doesn't use the full potential of multiple engines. Since our plane doesn't have a rudder, I changed the othermost motor's functions to throttle left and throttle right. This way we can change their speed based on the yaw stick movement, and it drastically improved the plane turning capabilities. You can experiment with how strong the effect is by changing this parameter. Next, to set up the control surfaces, I defined output 9 as elevator and made sure it moves in the correct way. But for ailerons, I decided to define them as flaperons instead. This makes them work just like standard ailerons, but when we need to land, we can just flip a switch and lower their position to increase lift. And lastly, for this first flight, I'm not enabling the airspeed sensor, since I have never used one before and I'm worried I might mess something up. So for now, let's just see if the plane can fly with only the GPS data. Alright, so hi everybody, we are now on the field and now I'm going to perform the first test flight of this modified lead glider. As you can see, we have a bit rough conditions because there's like a lot of wind, but we have some sunshine, which is rare this season, so that's pretty good. I have my Voxnail vision right here, it's turned on. I also have the plane armed right now. As you can see, the motors are all spinning. I confirmed that the control surfaces work well to level the plane in flight. As you can see, everything works. I'm going to start in the fly-by-wire A mode, which I think is the best for this purpose right now. And we are flying. This plane is really flying. Although it is a bit twitchy. And it's also really windy.
Let's try to fly closer to the ground. Okay. Oh, and the differential thrust also makes a difference. The conditions are really bad today, but the plane keeps going. It's not that bad. And also the weather is, I mean, we have some sunshine, so that's like the only day with sun in the December here in Poland. So let's make a good use out of it. Okay, you know, I think it's time to land. Okay, so the plane somehow survived this weather. It was really struggling, to be fair. Like, this wind is a bit too much for it, I think. Yeah, you can see how much I love Polish weather. My God. Okay, so I think I will charge the batteries now, change the airspeed sensor to be used, and we will try to do this flight again. Maybe the wind will calm down, but overall it was successful because it survived.
Well, that flight wasn't so bad. The plane took off nicely and I was able to stay in the air even though it was constantly getting blown away. The motors have definitely more thrust than the plane weight, which also helps in harsh conditions. Although they consume a lot of current at high throttle values, so I was trying to keep them under 50% to not damage my lithium battery. But anyway, now I feel confident to actually enable the airspeed sensor. To do that, first of all, you need to make sure what exact unit you have, and then define it in the airspeed tab. Next, for Ardupilot to actually use that data, you need to set airspeed use to 1. And then if you see the airspeed number change in Mission Planner HUD, then you know it works. Just keep in mind that by default, airspeed sensors calibrate each time you reboot your plane, and during calibration it's very important to cover it from the wind. For that purpose I use my old microphone dead cat, and it seems to work fine. There are also a few more parameters related to the airspeed sensors, so if you want to learn more, check out the Ardupilot wiki page. Last flight I also forget to set up my Voxnile OSD, so now to make it work we gotta change those few parameters. In the OSD configurator, I set up almost all possible panels to get as much data as possible, although I'm not sure what half of them even does. But there is one way to find out.
Okay, so hello again on the same field, and for this flight I did some changes. I made the roll and pitch limits larger, so that's one thing, and I also enabled the airspeed sensor, because the purpose of this is basically to determine what is the stall speed and what is the actual flying speed, because that's very important for the VTOL configuration during transitions. The flight controller needs to know what is the stall speed and how fast it's flying. So we will try to fly slow and determine this in this flight. And also this flight I want to test the flaperons, because we have this enabled right now. So we will see if I will be able to lower the stall speed with the flaperons. That might be really interesting. As you can see, it's getting a bit dark and it's kind of late, but there is less wind, so that's probably good. And one more thing I wanted to show you, because that's really cool, is the new radio I'm using, Radio Master TX16. You guys wrote me to buy a new radio because my old one was, well, a really old one. We call it Rzeźba in my science team. So now I have this one, and as you can see I have installed the Yapu script. So I have the offline maps right here, and I can see where the plane is on the offline map at all times. So that's really useful. And I basically also have the full Ardupilot HUD right here. So it's not two directional, I can only see it, but it's really useful. You know, when you have the goggles and that, you basically have the whole ground setup. So that's going to improve my project a lot, I think. I also have the gloves and this sweater because the weather in Poland sucks. really, really bad. My hands hopefully won't fall off from this cold. Alright, we have everything. And now if I look into the HUD, I can see that the current ground speed is like 0 and airspeed is 10 kilometers per hour. So that means the sensor is working. I think we can take off. I'm going to get a bit far, right here. And fly by wire A. And we are flying. All right. So this time it's a lot. Oh wait, I forgot to record. All right. Now we are recording. So this time there's a lot less wind. I can feel it already. It doesn't struggle as much. I can fly at like 30% throttle, so that's pretty good. Okay. All right. Let's do a low pass. Close to me. Okay, so we have like a 50 kilometers per hour speed right now, and it's cruising quite nicely. Now we are at 40. At 40 it gets quite unstable. So let's give it like 50% power. All right. At 50%, it flies quite nicely, it climbs. That's great. Let's do one more low pass. I think 50 kilometers per hour is okay. So now I'm going to try fly a bit further, and I'm going to enable the flaperons. We'll see how it will work out. Flaperons are down. We are flying at 25% throttle. I still got all the controls just right, so that's great. It's flying pretty nicely. It looks like it's staying in the air basically. But it flies. So 40% with flaperons. It's pretty good. It's pretty good. So you know, it flies quite well at low throttles. I will try to do the 30% throttle now. 30% throttle, flaperons are to the middle position, and it kind of looks like it's staying in the air in one place, but it actually flies. Wow, now it's really nice. It's really slow. That's really great. It basically stays in the air at these low throttle values, because at 30% throttle it consumes like only 4 amps, so it can stay in the air basically for a really long time. Oh, well, it crashed. I don't know why. I don't know what happened, to be fair. Well, that sucks, but I think it survived. It didn't look that bad. I mean, hopefully it survived. I don't really know what happened. It just like lost control. Maybe it was flying really too slow, or maybe there was some airspeed error, but it looked fine to me, so I don't know. But you know, that's part of the engineering process and the building process. You know, sometimes you get a crash to learn a thing or two. So here is the plane. Oh my god. Okay, so here everything is basically fine. The wing and the motors are fine. The servos are working. The pilot tube got really dirty, but I think I can just clean it up. I also need, this part broke, so I need to like glue it or print another one. The walk snail got a bit dirty, but it probably still is fine. I'm just happy this plane is still in one piece. But I think we kinda got the numbers we needed from that flight. Okay, see you guys. Let's get back to the basement.
Alright, so that was an interesting flight to say the least. Looking at the footage right now, I can clearly see that the plane simply stalled, and that's what caused the crash. There are many airplane stall videos on YouTube, and what my plane did looked very similar. I guess that I was putting too much hope in the Ardupilot stall prevention feature. But on the other hand, I was intentionally trying to achieve the lowest speed possible, so that's really only my fault. Luckily, these lead gliders are quite durable, and so the only thing that was damaged is the pitot tube mount. I will fix that later, but for now, since we got the airspeed data, we can finally start converting this plane into functional VTOL. So, to start, first I drilled 4 small holes in the wing carbon tubes. Then I got new, stronger 8mm carbon tubes and drilled them in the same spots. This way I can simply attach them to the bottom side of the wing with just M2 screws and nylon washers. Next I assembled my 3D printed motor mounts by screwing the motors to the top side and then connecting it to the bottom clamp. Now this small assembly can easily slide on the carbon tubes, and to fix it in place I just tightened these 2 screws. Later, of course, I had to enlarge the underwing wire canals, lead them all to the canopy and then solder all the wires to the second ESC, which I stacked on top of the first one. And just like that, the VTOL hardware is ready. Now let's configure the Ardupilot to make it work. To be fair, at the beginning I was worried that setting it up will be a tremendous task. But it's actually just like configuring a simple quadcopter. Once you set up Q-Enable to 1, you get access to new Mission Planner tabs. My favorite one is the Initial Tuning tab, which, just like in Arducopter, sets the optimal PID values based only on your battery and propeller size. But to make it fly, we also have to define the motor layout by setting Q-Frame class to 1 and Q-Frame type to 1 as well. Next, in the Servo Output tab, we have to define the 4 motors in a similar way to quadcopter setup. And finally, by setting one of the flight modes to Q-Hover, I was able to control all of them at once. At that point, I still had some reading to do about the inner workings of Ardupilot VTOLs, but I just couldn't wait to see this plane lift itself from the ground. So that was the first try, and it flies just like quadcopter. Honestly, watching as the plane control surfaces work in harmony with quadcopter movements really does some things to me. And even better is the fact that it flies smoothly on just the default PID profile. However, one thing that's not great is the yaw authority, but that is something that's usually bad on VTOL planes. Now, to prepare our VTOL for the proper flight, I set up some airspeed parameters. Most important is the airspeed min setting, which basically defines the transition speed. From the last flight, I learned the hard way that going below 40 km per hour is not the best idea, and since the VTOL plane is now about 150 grams heavier, I set the speed to higher value. To be extra safe, I also set up the Q assist speed, which should hopefully protect the plane from any stalls or servo failures. And there is even a setting to start assist below certain altitudes, which can prevent any hard ground crashes. Alright, I think that's all we need for basic setup. There are of course many more VTOL parameters, and I didn't talk about all of them, so I recommend reading the wiki if you want to learn more. But now, let's finally get this VTOL flying.
Alright guys, so this is the final test of our VTOL plane, and now, as you've seen before, it hovers quite nicely in just the hover mode, but now we'll try to start in hover mode and later do the transition in air, and also later I will try to land with transition. So, well, I hope it will work. I have high hopes in this plane because, you know, it survived few crashes and it still works, and actually it hovers really nice. So I think it might work. I believe in it. The plan is to start in Q-Hover, then I will just try to fill it for a minute or two, and then we will take off higher, and I will switch to fly-by-wire A. So then, according to Ardupilot Wiki, it should just by itself transition to the forward flight, like a fixed wing, and later we can just press Q hover at any time, and it will just slow in the air, and it will just hover like a drone, like a quadcopter. So I hope it's that easy. There were a lot of parameters. I might have messed something up, but I hope not. So now it's in Q hover, and if you can see, I can just do the throttle, and the vertical motor starts, right? So you can see this motor start, and not the horizontal ones. But if I switch to fly-by-wire A right now, well, now all of them kind of spin. So, well, it might work. Let's see. So, 3, 2, 1. So we're hovering. Look at that. The plane hovers in place. And now we are in Q hover, and let's see the Q loiter. Okay, so Q loiter basically keeps this plane in one place. So you can see it stays nicely in one place. It's actually quite stable. So that's great. And do I have the vision? I have the vision. So now let's get higher with this plane. All right. We are getting higher. And switching to fly-by-wire in 3, 2, 1, go! And it flies! It really flies! It was beautiful! Transitioned on! Wow! And it actually doesn't fly worse than before. I was worried the weight might keep it down, but it flies really well. This is incredible. My first VTOL plane, and it works the first time. Just amazing. Okay, and now let's try to do the landing. Differential thrust really helps here. And now let's just try to press hover. And we are in Q hover. So it's basically a drone now. And it flies like a drone, like a typical quadcopter. I can just stay in place.
So guys, that's all for this video. I did a couple more flights with this VTOL, and it really is a fun machine, but I don't want to put everything in this video because I'm too lazy to edit it. So if you want more details about this project, I will definitely publish the parameters and 3D files on my printables and Thingiverse, and I will also publish some more videos on my Patreon, so you can support me there if you want. But you know, I think it's a bit too heavy, like those 4 motors, they look cool, but they weigh more than just one bigger motor, and they consume more current. So for the second part, I think I would like to just cut them off and cut the tail off and just do one pusher motor, one bigger pusher motor, and do like a tail from the carbon tubes. So, you know, cut the tail, glue the motor here, extend the tubes, make the tail in the shape of V or A. I think that might be a big improvement. And I would also like to explore some autonomous modes like QRTL, the missions, you know, because there are a lot of parameters and I only scratched the surface of what the Ardupilot VTOLs are capable of. So I think it would be really interesting, but I would also love to hear what you guys think about this project. What do you think could be improved, what I messed up and what I did right? I'd really like your opinion on this. Because the ultimate goal is to create a platform for everyone to try and build their own VTOLs. Like, this was built from $5 Lidl glider toys. The fact that it's fully functional VTOL now, it's kind of amazing. But for now, thank you very much for watching. Thanks NordVPN for being a partner of today's video, and well, see you guys soon. And also, Happy New Year everyone!